Alright guys, so now we are going to start to problem number 10. In this problem number 10, what do we have? Use the transformation sketch to use transformation of graphs to sketch the graphs of y1 and y2. Graph y2 as dashed curve. Okay, so we're getting y1 equal absolute value of x, and y2 is going to be equal to absolute value of x minus 6. So if I decide to graph in blue, this is y1. Because we're having x minus 6, this 6, negative 6, minus 6 is inside the absolute value. That means I have to deal with an horizontal shift. And because it's a minus 6, that means it will be an horizontal shift to the right of 6 units. And if I represent in red, y2, 6 unit is right here. I'm getting right here y2. So the answer is supposed to be B. Okay, now let's take a look at the problem number 11. On the problem number 11, what do we have? On the problem number 11, give the equation of the function whose graph is described. So we got the graph of y equal x squared. The graph of y equal x squared is shifted 4 units to the left. Because it's shifted 4 units to the left, that means I'm going to have y equal x plus 4 square. Okay, shifted 4 units to the left. This graph is then vertically stretched by a factor 6. It is stretched vertically by a factor 6. That means I'm going to have y equal 6 times x plus 4 square. And then they are telling me it's reflected across the x-axis. So that means I'm going to have y equal negative 6x plus 4 square. The negative here is the negative correspond to a reflection across the x-axis. Okay, when this is the 6 correspond to a stretch of 6 times x plus 4 square. Alright, finally, the graph is shifted 7 units downward. So I'm going to end up to have negative 6 times x plus 4 square. Shifted 7 units downward, that means minus 7. Minus 7 correspond to a shift downward. And when you compare that with all the answers, the answer is supposed to be C. Alright, let's find the domain. Let's find the domain on this problem number 12 now. Let's find the domain of f of x 27 range f of x 03. So number 12, let f be a function with the given domain and range. Find the domain and range of the indicated function. So I got f of x on this problem number 12. We got f of x with a domain defined as a 2, 7 and a range defined as 0, 3. And we are calculating f of negative x. What is the domain for f of negative x? Well, in that case, the domain is going to be -7, -2, and the range is going to still be 0, 3. Okay, 0 and 3. And so the answer is supposed to be C. Alright. Okay, so now let's try to do problem number 13. And actually I'm going to do the problem number 13 on the side of the problem number 12. Problem number 13. And this problem number 13, what do we have? We're having the we're having the absolute value of the absolute value. Oh, let me just do one tiny thing right here. So we're having the absolute value of -6x minus 5 equal x. So we're having the absolute value of -6x minus 5 equal 8. And so that makes you think about this absolute value equal a, and you know that it's supposed to be the algebraic expression equal a or the algebraic expression equal -a. In that case, I'm going to have -6x -5 equal 8 or -6x -5 equal -8. I'm solving by adding 5 and I'm solving by adding 5. Now I'm getting -6x equal 13 and -6x equal -3. I divide by -6 both sides. And I end up to have x equal -13/6 or x equal -3 divided by -6 equal 1/2. So when I look at my answers, I'm supposed to find -13/6 and 1/2, and the answer is going to be B. Okay, I'll just remind you for the number 12 is C. So B, now let's try to do another one. Let's try to do the absolute value of -7 minus 6 greater than 2. Okay, so I'm on the problem number 14, and I have to deal with -7 minus 6x greater than 2. Okay guys, so that should make you think about algebraic expression greater than a number. And when you have your algebraic expression greater than a number, that means the algebraic expression is greater than a, or the algebraic expression is less than -a. In your case, you got -7 minus 6x greater than 2, or -7 minus 6x less than -2. I'm going to add 7, I'm going to add 7, I'm going to add 7, I'm going to add 7. First, I'm focusing on the symbol, and my symbol by adding doesn't change. Then I'm getting a -6x, and that is a 7 equal greater than 9, and -6x greater than 5. I divide by -6 everywhere. I have to divide by -6. And when I divide by -6, what is happening is I flip my symbol. And now I got x greater than 5 over -6 and x less than -3 over 2. So when I look at my interval notation, I'm going to have my number line. My 0 is right here. So I'm going to put my 0 right here because I'm dealing with only negative numbers. Okay, and I got -5 over 6 and -3 over 2. So -5 over 6 and then -3 over 2. X is greater than -5 over 6. So that means I need to go to the right. X is greater. And because there is no equal, parenthesis, x is less, that means I'm going to the right, to the left, and there is no equal in your symbol, so it's a parenthesis. The interval notation is going to be negative infinity, negative 3 over 2, parenthesis, parenthesis, union, negative parenthesis, negative 5 over 6, plus infinity. And when you look at the set of solution you had, the only one with negative infinity, negative 3, union negative 5 over 6 plus infinity is the answer D. Okay, now problem number 15. On the problem number 15, and let me do the problem number 15 on the side right here. So on the problem number 15, we are dealing with minus 10 plus 7x, minus 10 plus 7x equal, open another parenthesis, 7 minus 2x. 7 minus 2x. And that should make you think about the absolute value of x, of the algebraic expression equal an absolute value of another algebraic expression. And you are supposed to have the algebraic expression equal y, or the algebraic expression equal negative y. In that case, I'm going to have negative 10 plus 7x equals 7 minus 2x, or negative 10 plus 7x equal negative 7 minus 2x. I'm using my parentheses. So for this one, I'm going to add 2x, and I'm going to add 2x and add 10 both sides. Why do I do that? Because by doing so, no more x on one side of the equation and no more non-variable on the other side. Now I got 9x equals 17, so x equals 17 over 9. If I look at the other one, I'm going to first of all get rid of the parentheses by flipping on my symbol, equal negative 7 plus 2x. And obviously I'm going to do it, subtract 2x both sides and add 10 both sides. What is happening? No more x on the right side, no more non-variable on the left side. 7 minus 2x equal 5x equal negative 7 plus 10 plus 3, so x equal 3 over 5. 3 over 5. So I got two values of x, 17 over 9, and the second 3 over 5 for the number 15. And so the only one with 3 over 5 and 17 over 9, 3 over 5, 17 over 9, it is the answer C. Alright, answer C for this one. Number 16. Number 16, graph the functions. So if I want to graph these two functions, I need to understand that I have two. So let me rewrite that below right here. So I got number 16. On this problem number 16, what do we get? We get the function f of x equal 9x plus 6. Equal 9x plus 6 with a constraint saying that x has to be negative, strictly negative. And I have another function, f of x, equal what? Equal 2x squared minus 2, equal 2x squared minus 2, with a constraint being x has to be greater than or equal than 0. So x greater than or equal than 0. So for the first one, I'm getting a slope equal 9, a y-intercept equals 0.6. A y-intercept equals 0.6. For the number 2, I got a nonlinear function, so I just need to plug a few points, x and f of x. When x equals 0, I'm going to have negative 2. When x equals 1, I'm going to have 0. When x equals 2, I'm going to have 4 times 2, 8 minus 2, 6. When x equals negative 1, I'm going to get 0. When x equals negative 2, I'm going to get 4, 8 minus 2, 6. So same thing. Okay? So now if I graph these two functions, what am I supposed to have? Alright, so if I look at the first function, f of x equals 9x plus 6. Okay? F of x equals 9x plus 6. So if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, that is my y-intercept. Actually, my y-intercept is 0.6. Why do I continue to do That kind of mistake right here. So let me erase that.